Hi, everyone. Welcome to grade 12 maths. Yes, at our maths session. Hope everyone enjoyed the weekend and we are ready to work. And I also hope you were studying over the weekend. Sorry about that. Okay, so it's grade 12 math session and we're still doing differential calculus. Okay, so just to go through, okay, and my name is Vatseba Nkhabani. I'm your teacher for grade 12 maths. And this is my email address. It's my name, Vatseba Nkhabani. So it's my name and surname at gmail.com. So please note down my email address. It's my name, Vatseba Nkhabani. So it's my name and surname, Vatseba Nkhabani at gmail.com. So we're still doing differential calculus. Okay, so during the session, please just make sure that you're on mute and your videos are off. Please make sure that you're on mute and your videos are off. And also today we're gonna make a few changes. I'm gonna stop for questions after completing an example or an exercise, because I think when I move throughout the slides, you find that someone didn't get the first slide, and then when I continue, they still don't get what I'm doing. So I'll just stop. So I'll take questions after each example and exercise. But then if you don't have any questions during the session, or you're shy to ask, you can simply send me an email. So you can send me an email after the session. Okay. And then also, let's make sure that we only have maths related questions in our chats. So only maths related questions in our chats. So remember, today we're doing things different. I'm gonna take questions after an example or an exercise that I do before I move to the next one, okay? Okay, so today we're simply going to do derivative of functions using our differentiation rules. But then we're just gonna go through the differentiation rules again, because I think on Friday we moved too quickly through them. So today we'll just go through the rules again. So we'll just go through the rules slowly so that we understand. Okay. So, but then how we gonna see if we understand what are we gonna do? We're gonna go through problems. All right. So from Friday, we learned these rules. So from our rules of differentiation, you can simply see that this applies to if you have so you have a base and an exponent. So if you differentiate a function with a base and an exponent, and that exponent it's not 0, because remember, if you have a base and it's raised to the power of 0, it becomes what? 1. And 1 is a constant. Okay, so this n cannot be 0. Okay, so if you're differentiating that function, you take your exponent, you multiply it with your base, and then you raise your exponent, but then you subtract 1 from that exponent. Okay, that's the first rule. And then the second rule is if you have a constant, so your function in this case is a constant. So if you differentiate a constant, you will get 0. But then the other thing that you need to note is this dx. This dx simply means you are differentiating the function with respect to x. Please note that down. You are differentiating the function with regards to x. So this is with regards to x, with regards to x, with regards to x. Okay, good. So going back to the second rule, if you differentiate a constant, you will get 0. Another thing that you need to note is that if you differentiate a constant, multiply by, so we can write multiply by a function, then you simply just differentiate that function. So you differentiate the function and then you multiply that with the constant. Okay, so if it's a function multiplied by a constant, you differentiate the function and then you multiply by the constant. And then we also have the derivative of a sum. So if you have two functions, in this case we have f of x and g of x, and you're adding these functions, when you have to differentiate a sum, you simply differentiate the functions separately and you add them. Okay, same thing applies for a difference. How do we know if it's a difference? The minus sign. Okay, so if you are differentiating a difference, you differentiate the functions separately and you subtract them. Okay, so moving on to the problems. So let's say, so the problems I'm doing, they're actually from the homework I gave you on Friday. So on Friday, there was a homework that you had to do. So I'm doing a few solutions from those problems. I'm not going to do all of them. Okay, just to give you an overview of what you were supposed to do. So in this case, you are given a function which is y equals to okay. So if you're given a function and you have to find the derivative, you first have to identify what is it. So now we're given 10 multiplied by 7 minus 3. Okay, already we can see that our function is a constant, isn't it? So if it's a constant, it means we're gonna apply this rule. So we're simply gonna simplify. So we're gonna simplify our function. So we start by what's in the bracket, 7 minus 3, which is 4 times 10 is 40. And then we see that the derivative of a constant, because 40 is a constant, okay? So 40 is a constant. That's why the derivative of a constant is 0. So we applied this rule. Simply the derivative of a constant, which is 0. But then now, let's say you're given 16 So let's say you're given 16 x to the power of -2. What you will realize is that you have a 16, which is your constant, and that function. So we're applying this rule. Okay, so we're still differentiating with regards to x. So in this case, you will have to differentiate this and multiply by the 16. So how you do that is you take your exponent, this is your exponent, because we are applying the first rule. Okay, so your exponent multiplied by your base, and you subtract 1 from your exponent. Okay, but what we know is -2. If you add numbers with the same sign, then you will have 2 and 1, which is -3. So -2 minus 1 is 3. And then -2 times +16 will give you a negative. So this is what we get. So you will have -32, and this will give you -3. And from our rules, from the knowledge of rules of exponents, we know that we can write our answer in this form, which is -32 divided by x cubed. Okay. So remember, you can just move directly from this term to that term. It will depend on the marks. But then I'm just showing for those who will probably not understand why I wrote it in this form. So you can just easily move from this step to the last step. Or you can just leave it simply here. But then if you want to, you can just show all the steps. Okay. So you can leave, like I'm saying, you can leave your answer as -32x to the power of -3. I was just trying to show you that if you simplify it further, this is how we write it, according to our rules of exponents. Okay. So I'm going to do a few more examples, then we'll go to questions, because I can see you have a few questions. And then in this case, what we have a sum. So we have to differentiate the terms separately. And this is the same as number 2, and this is the same as number 1. So we will simply have, if we differentiate with respect to x, you will have your -5, which is your exponent. So your exponent multiplied by your base, and then you subtract 1 from your exponent. And we know that the derivative of a constant is 0. Okay, and then after that, you have your 5 minus 4, and your 5 multiplied by -4. So negative times positive is negative. And then you'll have -20x to the power of 4. Okay. Then next one, we have another sum. So it's x squared plus x plus 4. If we differentiate with regards to x, we'll have our exponent multiplied by our base. Our exponent, we subtract 1 plus this one, any number that an exponent, we know it's raised to the power of 1. So x has an exponent of 1. Hence, we have 1 minus 1, and we multiply by 1 here. Okay, and then the derivative of 4, it's 0. And then our answer is 2x, because 2 minus 1 is 1, and x to the power of 0, which is 1. So do you see why you need to see that this is raised to the power of 1? Because if you didn't see that it's raised to the power of 1, you would simply eliminate it. So it's good to know that it's raised to the power of 1, so that it's 1 minus 1, and anything raised to the power of 0, it's 1. Okay. And then, still same thing here. We have that, and our exponent, write this so that you don't confuse which 3 belongs where. So this 3 is actually our exponent. That's this exponent. So we multiply the 3 with the constant. And then our exponent, we subtract 1. Same thing, minus 2, which is our exponent. And then that. And then the derivative of a constant is 0. Okay. And then this is simply 3 divided by 1. So this 3 will cancel that 3, and you remain with x squared minus 2. This is raised to the power of 1. So x exponent 1. Same thing, we have another base which is raised to a fraction. We do the same procedure as we did in the previous one. We find the derivative will be 3 over 2. So our exponent multiplied by our base raised to the power, and then we subtract 1 from our exponent. And please, guys, revise fractions, because you're going to work with a lot of fractions, like adding and subtracting fractions, especially with different denominators. Okay. Then this will simply be 3 times 3, 9, because this 3 is basically 3 divided by 1. So remember, this is 3 divided by 1. So 3 times 3 is 9, 1 times 2 is 2, and then you have your 3 over 2 minus 1, which will give you a half. And then minus 4, remember this is raised to a power of 1. Hence we have 1 multiplied by x, 1 minus 1. And then I simplified it further. So you can leave it in this form and show that, okay, x exponent 0 is 1. Or you can write it in that form. Okay. So I'm going to quickly take questions. Okay. questions. See, Kyle was asking. Just gonna unmute you. Kyle? Kyle? Okay. So his question was, are we gonna do the derivative of a function? Yes, we're gonna do an intro to that. Number 6. Okay, let me check Kyle Mkize and then I'll come to Jadida. Okay, oh, it's Caleb Mkize.
Yes, yes.
Yes, you have a question with regards to number 6.
Yes, I have a question.
Okay.
I was wondering, why can't we write the answer as 9 over 2 x squared, 9 over 2, right? 9 over 2x, 9 over 2x to the power half minus 4.
You can do that. Yeah, you can do that. I was just trying to show you that if x is raised to the power of half, it's the same as square root of x.
Okay, thank you.
Yeah, so that let's say maybe from your original equation, you're given square root of x. Then you can write it in this form and then simplify using the derivative.
Okay, thank you.
Okay. There's a question from Jadida. Okay, Jadida.
Hi, ma'am. Could you
Yes.
please tell me how you would do the function that I sent on the chat?
Okay. I think we're gonna get to that towards the end.
Okay.
Yeah, we're gonna do something similar to that. Yeah, because today I just wanted, because I think on Friday I was moving too quickly, so there were some people who didn't understand how you change the exponent. So I just wanted to show you how you minus the one from the exponent. Then we can move to the other stuff. Okay.
Okay, thank you, ma'am.
Pleasure. Okay, there's also a question from, oh, okay, I think that's an answer. But yes, you simplify. Okay. So if you're given something like this, so the first thing that you do is to simplify. Okay. So math is simply a chain of everything that you learned. So everything that you learned in grade 1, you still applied in grade 12. Okay. So the easy way to work with this function, because you want to write it in the simplest form, like the form that's used in these 3 terms. So you want to either write it in this form, this one, or that one, where you have an exponent in exponential form, or you have a constant, or you have a constant multiplied by a function. So in this case, we didn't have that. So it simply means that we had to say x multiplied by x, which is x squared, x multiplied by 2, which is 2x plus 5. So now we have our x squared in this form. We can easily differentiate that using this rule. And then we can also differentiate that using the constant multiply the function, and then we have a constant. So finding the derivative of these separately, you'll have 2x still subtract 1 from your exponent plus the 2 that, and we know the derivative of a function is, of a constant is 0. So you'll have 2x plus 2. Okay. So the same thing with this one. You can either, there's 2 ways of doing it. You can either multiply your 200 throughout then differentiate each sum, or you can differentiate the what's in the bracket and then multiply by 200 at the end, which is what I did. Okay. So I found the derivative of each term and then multiply by the 200 afterwards. So remember, so this 3, that and that, the 2, this, and then here we have 1. Please don't forget this one. You're not given the exponent is 1. Okay, and the derivative of a constant or a number is 0. Okay, so the next step would be to simplify. But that's step twice. So you simplify your terms. This one will fall off, and then x exponent 0 is is 1. So x exponent 0 is 1, hence you remain with only 1 over 5 because it's 1 over 5 times 1. And then 2 minus 1, 1, 200 times 1. And then this is supposed to be what? Times 200. Did you see that? So here we're supposed to have 200. Okay, because we're multiplying throughout by the 200. So we're multiplying each term by the 200. Not forgetting this one, because it's x exponent 0, which is 1. And 1 times that times the 1 over 5. Okay. Then same thing with this one. You have 14 multiplied by, so you have binomial and another binomial. And what we know is you have to say this multiplied by that plus this multiplied by that, and this multiplied by that, also -1 times negative x squared. Okay, so we're still applying the rules that we learned. Yes, thank you for that. So the 1 over 5 we multiply by the 200. I just left it out. Glad that you can see that. Thanks, Kyle. And also, same thing. So remember, we always simplify first. We simplify to the, so we write our terms in the simplest form. Okay, then you have 1 over 2x. Then you have x cubed, negative times positive, negative half, and negative x squared. And then now you can either multiply throughout by 14. You can say 14 times that times that term, and the last term. Or you can differentiate what's in the brackets and then multiply by the 14 at the end. It's your choice, okay? So if you differentiate, you'll have the first term, 1 minus 1, which is x exponent 0, which is the same as 1. And then the second term will be 3x squared plus term 2x. And then you can multiply with the half or the 14 at the end. Okay. So, any questions? So do you guys have questions? So remember, we always simplify first. So you write your terms in the simplest form. You can either multiply with a constant and then do your differentiation, or you can differentiate, then multiply with your constant. It's your choice. Okay. So do you guys have questions? So exercise 2 number, okay, Chislin has a question. Let me just confirm. Okay. Chislin?
Hi, ma'am.
Yes, you have a question with regards to number 2.
Ma'am, could you please just go over it again, because I'm just a bit wary with this one.
Okay. It's simply like with the other ones that we did before. I think maybe it's just because it's longer or something. That's what I'm saying. There are 2 ways of solving the problem. You can either just multiply throughout with the 200, or remember it's the rule where they say if you have a constant and a function, you differentiate the function, then multiply by the constant, isn't it?
Yes,
So
ma'am.
that's what we are basically doing here for each term. We're differentiating each term because we have how many terms? 4 terms, 1, 2, 3, 4. So we're differentiating each term, and then afterwards we multiply with the 200. So back to the first rule. You take your exponent, multiply by your x, and then your new or your 1. Okay. And move the next term, which is negative half. This 2, and then you multiply with this term. That's why I say if it's x, always write to the power of 1, so that you can see that it's 1 minus 1, which is 0, and x raised to the power of 0 is what? It's 1. So you also apply.
For the end one, the 1/5 times 200 must be solved, or just leave it like that?
You can solve it. You can say 200 divided by 5, and then you get your answer.
Okay.
Yes. So it's just doing differentiation of each term. You still apply the same rule, but then you do it term by term.
Okay.
So here, that's what I'm saying. It's good to also check your answer, because here I didn't multiply. When I was doing my calculations, I didn't multiply the last term with 200. So that's what I'm showing you now, that because this is 1 times 1/5. But then we still need to multiply with the 200.
200.
Yes, because we did that. Because with this middle term, this 2 will cancel the other 2. So this 2 will cancel that one, and you'll remain with 1x, because it's x to the power of 1. Let me just show that. This will be x to the power of 1, because it's 2 minus 1. This 2 will cancel that 2, and then you remain with 1 times x times 200. Hence, we have 200x.
Okay, ma'am.
Okay. But then the more you practice, you'll see that it's actually, like, you can even just move from your question to the final answer, or do it with 3 steps, yeah, when you do more problems. Okay.
Okay, thank you, ma'am.
Pleasure. Any other question? Okay. your marks will always direct you into how many marks you need. Okay, so if you get this question and you get and it's only 1 mark, it probably means they'll just mark the final answer. But you can write the steps to make sure that you're doing the right things. That's good. But then you will only get 1 mark. So when you practice more, you'll get, like you can see, because for example, this is simply 2x because you subtracted 1. But then when you practice more, yeah. And the marks in the exam will always direct you. So you'll see when we do question papers, how they mark. Okay. Questions, guys? You can raise your hand if you have a question. Okay, but what you'll notice from what we've done so far is that you need to revise your rules for exponents. So it's really good that you revise your rules for exponents and addition and subtraction of fractions, and also how to simplify if you have a binomial, multiply by a binomial. So you need to revise all that. Okay. So try to go through past papers on the DBE website, but we'll also do that. So we're gonna go through a question paper on Wednesday. Just practice. Okay. So let's say you're given something like this and you differentiate with regards to a y. So like I said, we always simplify. Say if you have x equals to 2y plus 3. So always remember, if a number goes over an equal sign, it changes sign. So you had a plus 3 here. Now it's negative 3. Okay. And to remain with y, you're going to do what? You're going to divide both sides with 2. So you're going to divide throughout with 2. Hence, you have this term. Okay. Now, if you're differentiating with regards to x, it means you focus on your x. Okay, so still the same thing. Remember, this is raised to the power of 1, and then this is a constant. So derivative of a constant is 0. Okay, and then you'll have x to the power of 0, which is 1. So 1 times 1 times a half, your answer will be half. But then imagine if you had the same question. So think about it. And then you were supposed to determine dx over dy. So just think about it. So imagine if you had the same question, but then you had to find dx of dy. So this means your function in this case is this, is in terms of x, but then now you have to differentiate y. So what do you think it's gonna be different? So this is something for you to think about. In this case, we were doing dy, dx. And I said this means this is our function. So we're differentiating y with regards to x. So what then if you have dx dy? This means you have to differentiate x with regards to y. So the answer for this will simply be what? If we're using the same term. So dx, so it's x, that dy, this will simply be 2. Okay, because now we are differentiating with regards to y. Probably most of the time they will give you the question showing you if you have to find dy dx or f prime. But if they say f prime x, then you know it's simply at. Okay. And then last one, this is a function of t. So this is simply x, which is a function of t. And then let's have t squared. Don't be alarmed. It's just that your x is with it's a function of t. Okay. So if you're gonna find dx dt, it means you're differentiating x with regards to t. Okay. So you simply your 2, the same thing we were doing with x. So don't be stressed if now they use different letters like z or k. So it's still the same procedure. See? So your 2, which is your exponent, and then this is raised to the power of 1. And 1 minus 1 here, there's multiplied by 1. And then your answer will be t to the power of 0, which is 1. And then this 2 will cancel that 2 divided by 2. And this will be your final answer. Okay, so Shalom has a question, and then we'll quickly go to the homework. Shalom. Hi, Shalom. Shalom. Yes, you have a question?
Ma'am?
Yes, you were asking. Okay,
I wanted
in the
to ask.
Yes.
No, ma'am, carry on, it's fine.
No, you can ask. You were asking. Shalom.
Oh, ma'am. Oh, yes, ma'am. Ma'am, I wanted to know. We start off with y, like number 1, started off with x, and then we changed it to y. And then we said y is equal to 1 over 2x minus 3 over 2. Why is it necessary to change back to dy over dx, or can we just leave it as y as we go along?
Okay, if you're differentiating, okay, dy dx means you are differentiating y with regards to x. Okay. So if you're differentiating y with regards to x, it means your function has to be in terms of y.
Okay.
Like you solve, you have y equals to something. Do you get it? Yes. But then if this changes, because I've seen a paper where they changed, instead of saying dy dx, they wanted you to do both. So they wanted you to find dy dx and also find dx dy. It's just to check if you understand that, okay, if I'm differentiating y with regards to x, it means on my right-hand side of my equation, I'll have terms with x and I will differentiate that. But then if it's dx dy, it means I just take the function as is because I have x in terms of y. So my output is x, my input will be y. So you're differentiating x with regards to y. That's why I said, because y is raised to the power of 1. So this will be 1. That's why your answer is 2. But then when you find dy dx, your answer is half. But then they will always specify, yes, in the exam, they will always specify. But then if it's f prime x, then you know that your function is f. So your output is f, and then your input is x. Do you see the difference?
Yes, ma'am.
Yeah, so even with this one, we can write it as x. So this will be x prime of t. So it's the same as that.
Oh, okay. So dy over dx is also the same as f prime x.
Yes. So no, dy
right.
dx is the same as y prime.
Y prime x. Oh, okay.
Yes, y prime. Or if you want to show that it's, but then I think it might be confusing for someone, so you can write it in this form.
Okay, ma'am.
Yes. Okay.
Thank you, ma'am.
Okay. So you're welcome. So guys, this is your homework. So it's from the Siyavula grade 12 textbook, because most of the problems I'm doing, they're from the Siyavula textbook. And so we're doing examples and exercises from Siyavula grade 12 textbook. So these are the questions that I need you guys to do. So try these and then we'll work them out tomorrow. Okay. So we have, so just copy down the questions, try them, and then tomorrow we'll try to finish. One last question. We have time for one question. Okay, let's try Cheslin quickly. Cheslin?
Ma'am?
Cheslin? Yes, you have a question.
No, it was okay. It was the about the variables and if it's different. So if dx is on top of dy and all that. But ma'am, when you explained to Shalom, I understood. But ma'am, I did want to ask
great.
about the first question in the homework. Am I right in saying to remove a square root, we can just take it and we just have to do, we have to make it into an exponent, right? We can't work with the square root.
Yes, that's why I said we need to revise rules for exponents.
Okay. Ma'am, is there any other topics we should be focusing on?
With regards, because this week we're simply gonna do derivatives, and then we're gonna do still derivatives, but then when you find the equation of what's this, of a tangent.
Okay, ma'am.
So this week we're simply gonna do derivatives and do question papers on derivatives. And then next week, because it's a long chapter, it's still derivatives, but then sometimes you do word problems. But then
okay, ma'am.
after that, that's when we can start with a new chapter.
Okay. Thank you, ma'am.
It's a pleasure. So guys, tomorrow, still derivatives. Okay.